What is a neural network, and why does it seem to do such a surprisingly good job of learning?
What is a neural network? It's a mathematical abstraction of the brain, I would say. That's how it was originally developed. At the end of the day, it's a mathematical expression, and it's a fairly simple mathematical expression when you get down to it. It's basically a sequence of matrix multiplies, which are really dot products mathematically, and some nonlinearity is thrown in. And so it's a very simple mathematical expression, and it's got knobs in it.
Many knobs.
Many knobs. And these knobs are loosely related to basically the synapses in your brain. They're trainable, they're modifiable. And so the idea is we need to find the setting of the knobs that makes the neural net do whatever you want it to do, like classify images and so on. And so there's not too much mystery, I would say, in it. You might think that basically you don't want to endow it with too much meaning with respect to the brain and how it works. It's really just a complicated mathematical expression with knobs, and those knobs need a proper setting for it to do something desirable.
Yeah, but poetry is just a collection of letters with spaces, but it can make us feel a certain way. And in that same way, when you get a large number of knobs together, whether it's inside the brain or inside a computer, they seem to surprise us with their power.
Yeah, I think that's fair. So basically, I'm underselling it by a lot because you definitely do get very surprising emergent behaviors out of these neural nets when they're large enough and trained on complicated enough problems, like say, for example, the next word prediction in a massive data set from the internet. And then these neural nets take on pretty surprising magical properties. Yeah, I think it's kind of interesting how much you can get out of even very simple mathematical formalism.
When your brain right now is talking, is it doing next word prediction? Or is it doing something more interesting?
Well, it's definitely some kind of a generative model that's a GPT-like and prompted by you.
Yes.
So you're giving me a prompt and I'm kind of responding to it in a generative way.
And by yourself, perhaps a little bit? Are you adding extra prompts from your own memory inside your head? Or no?
Well, it definitely feels like you're referencing some kind of a declarative structure of memory and so on. And then you're putting that together with your prompt and giving away some answer.
How much of what you just said has been said by you before?
Nothing, basically, right?
No, but if you actually look at all the words you've ever said in your life and you do a search, you'll probably have said a lot of the same words in the same order before.
Yeah, could be. I mean, I'm using phrases that are common, etc., but I'm remixing it into a pretty sort of unique sentence at the end of the day. But you're right, definitely there's a ton of remixing.
Why you didn't? It's like Magnus Carlsen said, I'm rated 2900 whatever, which is pretty decent. I think you're talking very, you're not giving enough credit to neural nets here. Why do they seem to, what's your best intuition about this emergent behavior?
I mean, it's kind of interesting because I'm simultaneously underselling them, but I also feel like there's an element to which I'm it's actually kind of incredible that you can get so much emergent magical behavior out of them, despite them being so simple mathematically. So I think those are kind of two surprising statements that are kind of juxtaposed together. And I think basically what it is we are actually fairly good at optimizing these neural nets. And when you give them a hard enough problem, they are forced to learn very interesting solutions in the optimization. And those solutions basically have these emergent properties that are very interesting.
There's wisdom and knowledge in the knobs.
Mm-hmm.
And so
yes.
This representation that's in the knobs, does it make sense to you intuitively that a large number of knobs can hold a representation that captures some deep wisdom about the data it has looked at? It's a lot of knobs.
It's a lot of knobs. And somehow, so speaking concretely, one of the neural nets that people are very excited about right now are GPTs, which are basically just next word prediction networks. So you consume a sequence of words from the internet and you try to predict the next word. And once you train these on a large enough data set, you can basically prompt these neural nets in arbitrary ways and you can ask them to solve problems and they will. So you can just tell them, you can make it look like you're trying to solve some kind of a mathematical problem, and they will continue what they think is the solution based on what they've seen on the internet. And very often, those solutions look very remarkably consistent, look correct potentially even.
So what are strengths and limitations of cameras for the driving task, in your understanding? When you formulate the driving task as a vision task with 8 cameras, you've seen the entire, most of the history of the computer vision field when it has to do with neural networks. Just if you step back, what are the strengths and limitations of pixels, of using pixels to drive?
Yeah, pixels, I think, are a beautiful sensor, I would say. The thing is, like, cameras are very, very cheap, and they provide a ton of information, ton of bits. So it's extremely cheap sensor for a ton of bits. And each one of these bits is a constraint on the state of the world. And so you get lots of megapixel images, very cheap. And it just gives you all these constraints for understanding what's actually out there in the world. So vision is probably the highest bandwidth sensor. It's a very high bandwidth sensor. And
I love that pixels is a constraint on the world. It's this highly complex high bandwidth constraint on the world, on the state of the world. That's fascinating.
And it's not just that, but again, this real importance of it's the sensor that humans use. Therefore, everything is designed for that sensor.
Yeah.
The text, the writing, the flashing signs, everything is designed for vision. And so you just find it everywhere. And so that's why that is the interface you want to be in. Talking again about these universal interfaces. And that's where we actually want to measure the world as well, and then develop software for that sensor.
But there's other constraints on the state of the world that humans use to understand the world. I mean, vision ultimately is the main one, but we're like referencing our understanding of human behavior and some common sense physics that could be inferred from vision from a perception perspective, but it feels like we're using some kind of reasoning to predict the world,
100%.
Not just the pixels.
I mean, you have a powerful prior for how the world evolves over time, etc. So it's not just about the likelihood term coming up from the data itself, telling you about what you are observing, but also the prior term of like where are the likely things to see and how do they likely move and so on.
And the question is, how complex is the range of possibilities that might happen in the driving task?
Right.
That's still is that to you still an open problem of how difficult is driving, like philosophically speaking? Like, do you all the time you worked on driving, do you understand how hard driving is?
Yeah, driving is really hard because it has to do with the predictions of all these other agents and the theory of mind, and what they're going to do, and are they looking at you? Where are they looking? Where are they thinking?
Yeah,
there's a lot that goes there at the full tail of the expansion of the nines that we have to be comfortable with. It eventually, the final problems are of that form. I don't think those are the problems that are very common. I think eventually they're important, but it's like really in the tail end.
In the tail end, the rare edge cases.
Yes.
From the vision perspective, what are the toughest parts of the vision problem of driving?
Well, basically, the sensor is extremely powerful, but you still need to process that information. And so going from brightnesses of these pixel values to, hey, here's the three-dimensional world is extremely hard. And that's what the neural networks are fundamentally doing. And so the difficulty really is in just doing an extremely good job of engineering the entire pipeline, the entire data engine, having the capacity to train these neural nets, having the ability to evaluate the system and iterate on it. So I would say just doing this in production at scale is like the hard part. It's an execution problem.
So the data engine, but also the sort of deployment of the system such that it has low latency performance.
Yes.
So it has to do all these steps.
Yeah, for the neural net specifically, just making sure everything fits into the chip on the car.
Yeah.
And you have a finite budget of flops that you can perform, and memory bandwidth and other constraints. And you have to make sure it flies. And you can squeeze in as much compute as you can into the tiny.
What have you learned from that process? Because maybe that's one of the bigger, new things coming from a research background, where there's a system that has to run under heavily constrained resources,
right,
has to run really fast. What kind of insights have you learned from that?
Yeah, I'm not sure if there's too many insights. You're trying to create a neural net that will fit in what you have available, and you're always trying to optimize it. And we talked a lot about it on the AI day, and basically the triple backflips that the team is doing to make sure it all fits and utilizes the engine. So I think it's extremely good engineering. And then there's all kinds of little insights peppered in on how to do it properly.
Let's actually zoom out, because I don't think we talked about the data engine, the entirety of the layouts, of this idea that I think is just beautiful, with humans in the loop. Can you describe the data engine?
Yeah, the data engine is what I call the almost biological feeling like process by which you perfect the training sets for these neural networks. So because most of the programming now is in the level of these data sets and make sure they're large, diverse, and clean, basically you have a data set that you think is good, you train your neural net, you deploy it, and then you observe how well it's performing. And you're trying to always increase the quality of your data set. So you're trying to catch scenarios basically that are basically rare. And it is in these scenarios that the neural nets will typically struggle in because they weren't told what to do in those rare cases in the data set. But now you can close the loop because if you can now collect all those at scale, you can then feed them back into the reconstruction process I described and reconstruct the truth in those cases and add it to the data set. And so the whole thing ends up being like a staircase of improvement of perfecting your training set. And you have to go through deployments so that you can mine the parts that are not yet represented well in the data set. Mm-hmm. So your data set is basically imperfect. It needs to be diverse. It has pockets that are missing, and you need to pad out the pockets. You can sort of think of it that way in the data.
What role do humans play in this? So what's the this biological system, like a human body is made up of cells? What role, like how do you optimize the human system, the multiple engineers collaborating, figuring out what to focus on, what to contribute, which task to optimize in this neural network, who's in charge of figuring out which task needs more data? What can you speak to the hyperparameters of the human system?
It really just comes down to extremely good execution from an engineering team who knows what they're doing. They understand intuitively the philosophical insights underlying the data engine and the process by which the system improves, and how to, again, like delegate the strategy of the data collection and how that works, and then just making sure it's all extremely well executed. And that's where most of the work is not even the philosophizing or the research or the ideas of it. It's just extremely good execution. It's so hard when you're dealing with data at that scale.
So your role in the data engine, executing well on it, is difficult and extremely important. Is there a priority of like a vision board of saying like, we really need to get better at stoplights? Yep. Like the prioritization of tasks. Yes. Is that essentially, and that comes from the data?
That comes to a very large extent to what we are trying to achieve in the product roadmap, the release we're trying to get out, in the feedback from the QA team where the system is struggling or not, the things we're trying to improve.
And the QA team gives some signal, some information in aggregate about the performance of the system in various conditions.
That's right. And then, of course, all of us drive it, and we can also see it. It's really nice to work with a system that you can also experience yourself, and it drives you home. Is there some insight you can draw from your individual experience that you just can't quite get from an aggregate statistical analysis of the data? Yeah.
It's so weird, right?
Yes.
It's not scientific in a sense because you're just one anecdotal sample.
Yeah, I think there's a ton of it's a source of truth. It's your interaction with the system, and you can see it, you can play with it, you can perturb it, you can get a sense of it, you have an intuition for it. I think numbers just like have a way of numbers and plots and graphs are much harder. It hides a lot of.
It's like if you train a language model. It's a really powerful way is by you interacting with it.
Yeah, 100%.
Try to build up an intuition.
Yeah, I think like Elon also he always wanted to drive the system himself. He drives a lot, and I want to say almost daily. So he also sees this as a source of truth. You driving the system and it performing, and
So what do you think? Tough questions here. So Tesla last year removed radar from the sensor suite, and now just announced that it's going to remove ultrasonic sensors, relying solely on vision, so camera only. Does that make the perception problem harder or easier?
I would almost reframe the question in some way. So the thing is basically, you would think that additional sensors...
By the way, can I just interrupt?
Go ahead.
I wonder if a language model will ever do that if you prompt it. Let me reframe your question. That would be epic. That's the wrong prompt. Sorry.
So it's like a little bit of a wrong question because basically you would think that these sensors are an asset to you.
Yeah.
But if you fully consider the entire product in its entirety, these sensors are actually potentially a liability because these sensors aren't free. They don't just appear on your car. You need Suddenly you need to have an entire supply chain. You have people procuring it. There can be problems with them. They may need replacement. They are part of the manufacturing process. They can hold back the line in production. You need to source them. You need to maintain them. You have to have teams that write the firmware, all of it. And then you also have to incorporate them, fuse them into the system in some way. And so it actually like bloats a lot of it. And I think Elon is really good at simplify. Best part is no part. And he always tries to throw away things that are not essential because he understands the entropy in organizations and an approach. And I think in this case, the cost is high and you're not potentially seeing it if you're just a computer vision engineer. And I'm just trying to improve my network and, is it more useful or less useful? How useful is it? And the thing is, if once you consider the full cost of a sensor, it actually is potentially a liability. And you need to be really sure that it's giving you extremely useful information. In this case, we looked at using it or not using it, and the delta was not massive. And so it's not useful.
Is it also bloat in the data engine? Like having more sensors?
100%.
Is a distraction?
And these sensors, they can change over time. For example, you can have one type of, say, radar. You can have other type of radar. They change over time. Now suddenly you need to worry about it. Now suddenly you have a column in your SQLite telling you, which sensor type was it? And they all have different distributions. And then they contribute noise and entropy into everything. And they bloat stuff. And also organizationally, it's been really fascinating to me that it can be very distracting. If all you want to get to work is vision, all the resources are on it, and you're building out a data engine, and you're actually making forward progress because that is the sensor with the most bandwidth, the most constraints in the world, and you're investing fully into that, and you can make that extremely good. If you have only a finite amount of sort of spend of focus across different facets of the system.
And this kind of reminds me of Rich Sutton's The Bitter Lesson. That just seems like simplifying the system.
Yeah.
In the long run. Now, of course, you don't know what the long run is. It seems to be always the right solution.
Yeah. Yes.
In that case, it was for RL, but it seems to apply generally across all systems that do computation.
Yeah.
So what do you think about the LiDAR as a crutch debate? The battle between point clouds and pixels.
Yeah, I think this debate is always like slightly confusing to me because it seems like the actual debate should be about like, do you have the fleet or not? That's like the really important thing about whether you can achieve a really good functioning of an AI system at this scale.
So data collection systems.
Yeah, do you have a fleet or not is significantly more important whether you have LiDAR or not. It's just another sensor. I think similar to the radar discussion, basically, I don't think it basically doesn't offer extra information. It's extremely costly. It has all kinds of problems. You have to worry about it. You have to calibrate it, etc. It creates bloat and entropy. You have to be really sure that you need this sensor. In this case, I basically don't think you need it. And I think, honestly, I will make a stronger statement. I think the others, some of the other companies that are using it are probably going to drop it.
Yeah, so you have to consider the sensor in the full. In considering, can you build a big fleet that collects a lot of data, and can you integrate that sensor with that data and that sensor into a data engine that's able to quickly find different parts of the data that then continuously improves whatever the model that you're using? Yeah,
another way to look at it is like vision is necessary in the sense that the world is designed for human visual consumption, so you need vision. It's necessary, and then also it is sufficient. Because it has all the information that you need for driving, and humans obviously use vision to drive. So it's both necessary and sufficient. So you want to focus resources, and you have to be really sure if you're going to bring in other sensors. You could add sensors to infinity. At some point, you need to draw the line. And I think in this case, you have to really consider the full cost of any one sensor that you're adopting, and do you really need it? And I think the answer in this case is no.
So what do you think about the idea that the other companies are forming high-resolution maps and constraining heavily the geographic regions in which they operate? Is that approach not, in your view, not going to scale over time to the entirety of the United States?
I think
it'll take too
as
long.
You mentioned, like they pre-map all the environments and they need to refresh the map. And they have a perfect centimeter level accuracy map of everywhere they're going to drive. It's crazy. How are you going to... When we're talking about autonomy actually changing the world, we're talking about a deployment on a global scale of autonomous systems for transportation. And if you need to maintain a centimeter accurate map for Earth or like for many cities and keep them updated, it's a huge dependency that you're taking on, huge dependency. it's a massive, massive dependency. And now you need to ask yourself, do you really need it? And humans don't need it, right? So it's very useful to have a low-level map of like, okay, the connectivity of your road. You know that there's a fork coming up. When you drive an environment, you sort of have that high-level understanding. It's like a small Google map. And Tesla uses Google Map, like similar kind of resolution information in its system, but it will not pre-map environments to centimeter level accuracy. It's a crutch. It's a distraction. It costs entropy. And it diffuses the team. It dilutes the team. And you're not focusing on what's actually necessary, which is the computer vision problem.
What did you learn about machine learning, about engineering, about life, about yourself as one human being from working with Elon Musk?
I think the most I've learned is about how to sort of run organizations efficiently and how to create efficient organizations and how to fight entropy in an organization.
So human engineering in the fight against entropy.
Yeah. I think Elon is a very efficient warrior in the fight against entropy in organizations.
What does entropy in an organization look like exactly?
It's process, it's process and
inefficiencies in the form of meetings and that kind of stuff.
Yeah, meetings. He hates meetings. He keeps telling people to skip meetings if they're not useful. Yeah. He basically runs the world's biggest startups, I would say. Tesla, SpaceX are the world's biggest startups. Tesla actually is multiple startups. I think it's better to look at it that way. And so I think he's extremely good at that. And he has a very good intuition for streamlining processes, making everything efficient. Best part is no part, simplifying, focusing, and just kind of removing barriers, moving very quickly, making big moves. All of this is very startup-y sort of seeming things, but at scale.
So strong drive to simplify. Yeah. From your perspective, I mean, that also probably applies to just designing systems in machine learning and otherwise. Yeah. Like simplify.
Yes.
What do you think is the secret to maintaining the startup culture in a company that grows? Is there, can you introspect that?
I do think you need someone in a powerful position with a big hammer, like Elon, who's like the cheerleader for that idea and ruthlessly pursues it. If no one has a big enough hammer, everything turns into committees, democracy within the company, process, talking to stakeholders, decision-making, just everything just crumbles. Yeah. If you have a big person who's also really smart and has a big hammer, things move quickly.
So you said your favorite scene in Interstellar is the intense docking scene with the AI and Cooper talking, saying, Cooper, what are you doing? Docking, it's not possible. No, it's necessary. Such a good line. By the way, just so many questions there. Why an AI in that scene presumably is supposed to be able to compute a lot more than the human is saying it's not optimal? Why the human? I mean, that's a movie, but shouldn't the AI know much better than the human? Anyway, what do you think is the value of setting seemingly impossible goals? So like our initial intuition, which seems like something that you have taken on, that Elon espouses, that where the initial intuition of the community might say this is very difficult, and then you take it on anyway with a crazy deadline. You just from a human engineering perspective, have you seen the value of that?
I wouldn't say that setting impossible goals exactly is a good idea, but I think setting very ambitious goals is a good idea. I think there's what I call sublinear scaling of difficulty, which means that 10x problems are not 10x hard. Usually 10x harder problem is like 2 or 3x harder to execute on. Because if you want to actually if you want to improve a system by 10%, it costs some amount of work. And if you want to 10x improve the system, it doesn't cost 100x amount of the work. And it's because you fundamentally change the approach. And if you start with that constraint, then some approaches are obviously dumb and not going to work. And it forces you to reevaluate. And I think it's a very interesting way of approaching problem solving.
But it requires a weird kind of thinking. It's just going back to your PhD days. It's like, how do you think which ideas in the machine learning community are solvable?
Mm-hmm. Yes.
It requires, what is that? I mean, there's the cliche of first principles thinking, but it requires to basically ignore what the community is saying. Because doesn't a community in science usually draw lines of what is and isn't possible?
Right.
And it's very hard to break out of that without going crazy.
Yeah. I mean, I think a good example here is, the deep learning revolution in some sense, because you could be in computer vision at that time during the deep learning sort of revolution of 2012 and so on. You could be improving a computer vision stack by 10%, or you can just be saying, actually, all of this is useless. And how do I do 10x better computer vision? Well, it's not probably by tuning a hog feature detector. I need a different approach. I need something that is scalable. Going back to Richard Sutton's and understanding sort of like the philosophy of the bitter lesson, and then being like, actually, I need a much more scalable system, like a neural network, that in principle works, and then having some deep believers that can actually execute on that mission and make it work. So that's the 10x solution.
What do you think is the timeline to solve the problem of autonomous driving? That's still in part an open question.
Yeah, I think the tough thing with timelines of self-driving, obviously, is that no one has created self-driving.
Yeah.
So it's not like, what do you think is a timeline to build this bridge? Well, we've built 1,000,000 bridges before. Here's how long that takes. No one has built autonomy. It's not obvious. Some parts turned out to be much easier than others. So it's really hard to forecast. You do your best based on trend lines and so on, and based on intuition. But that's why fundamentally it's just really hard to forecast this. No one has.
So even still, like being inside of it, it's hard to do.
Yes, some things turn out to be much harder, and some things turn out to be much easier.
Do you try to avoid making forecasts? Because like Elon doesn't avoid them, right? And heads of car companies in the past have not avoided it either. Ford and other places have made predictions that we're going to solve level 4 driving by like 2020, 2021, whatever. And now they all kind of backtrack on that prediction. Are you, as an AI person, do you for yourself privately make predictions, or do they get in the way of like your actual ability to think about a thing?
Yeah, I would say like what's easy to say is that this problem is tractable, and that's an easy prediction to make. It's tractable. So it's going to work. Yes, it's just really hard. Some things turn out to be harder, and some things turn out to be easier. But it definitely feels tractable, and it feels like at least the team at Tesla, which is what I saw internally, is definitely on track to that.
How do you form a strong representation that allows you to make a prediction about tractability? So like you're the leader of a lot of humans. You have to kind of say this is actually possible. Like, how do you build up that intuition? It doesn't have to be even driving. It could be other tasks. It could be. What difficult tasks did you work on in your life? I mean, classification, achieving certain, just on ImageNet, certain level of superhuman level performance.
Yeah, expert intuition. It's just intuition. It's belief.
So just like thinking about it long enough, like studying, looking at sample data, like you said, driving. My intuition is really flawed on this. Like I don't have a good intuition about tractability. It could be either. It could be anything. It could be solvable. Like the driving task could be simplified into something quite trivial. Like the solution to the problem would be quite trivial. And at scale, more and more cars driving perfectly might make the problem much easier. Like the more cars you have driving, and like people learn how to drive correctly, not correctly, but in a way that's more optimal for a heterogeneous system of autonomous and semi-autonomous and manually driven cars. That could change stuff. Then again, also I've spent a ridiculous number of hours just staring at pedestrians crossing streets and thinking about humans. And it feels like the way we use our eye contact, it sends really strong signals, and there's certain quirks and edge cases of behavior. And of course, a lot of the fatalities that happen have to do with drunk driving, and both on the pedestrian side and the driver's side. So there's that problem of driving at night and all that kind of.
Yeah.
So I wonder, it's like the space of possible solution to autonomous driving includes so many human factor issues that it's almost impossible to predict. There could be super clean, nice solutions.
Yeah, I would say definitely, like, to use a game analogy, there's some fog of war, but you definitely also see the frontier of improvement, and you can measure historically how much you've made progress. And I think, for example, at least what I've seen in roughly 5 years at Tesla, when I joined, it barely kept lane on the highway. I think going up from Palo Alto to SF was like 3 or 4 interventions. Anytime the road would do anything geometrically or turn too much, it would just like not work. And so going from that to like a pretty competent system in 5 years and seeing what happens also under the hood and what the scale at which the team is operating now with respect to data and compute and everything else is just massive progress. So
it's you're climbing a mountain and
yes.
It's fog, but you're making a lot of progress.
It's fog. You're making progress and you see what the next directions are. And you're looking at some of the remaining challenges and they're not like, they're not perturbing you and they're not changing your philosophy and you're not contorting yourself. You're like, actually, these are the things that we still need to do.
Yeah, the fundamental components of solving the problem seem to be there, from
yes.
the data engine to the compute to the compute on the car to the compute for
yes.
the training, all that kind of stuff. So you've done, over the years you've been at Tesla, you've done a lot of amazing breakthrough ideas in engineering, all of it, from the data engine to the human side, all of it. Can you speak to why you chose to leave Tesla?
Basically, as I described, I think over time during those 5 years, I've kind of gotten myself into a little bit of a managerial position. Most of my days were, meetings and growing the organization and making decisions about sort of high-level strategic decisions about the team and what it should be working on and so on. And it's kind of like a corporate executive role, and I can do it. I think I'm okay at it, but it's not like fundamentally what I enjoy. And so I think when I joined, there was no computer vision team because Tesla was just going from the transition of using Mobileye, a third-party vendor for all of its computer vision, to having to build its computer vision system. So when I showed up, there were 2 people training deep neural networks, and they were training them at a computer at their legs, like down.
They're doing some kind of basic classification task.
Yeah, and so I kind of like grew that into what I think is a fairly respectable deep learning team, a massive compute cluster, a very good data annotation organization, and I was very happy with where that was. It became quite autonomous. And so I kind of stepped away and I'm very excited to do much more technical things again. Yeah. And kind of like refocus on AGI.
What was that soul searching like? Because you took a little time off and think like how many mushrooms did you take? No, I'm just kidding. I mean, what was going through your mind? The human lifetime is finite.
Yeah.
You did a few incredible things. You're one of the best teachers of AI in the world. You're one of the best, and I don't mean that, I mean that in the best possible way. You're one of the best tinkerers in the AI world, meaning like understanding the fundamentals of how something works by building it from scratch and playing with the basic intuitions. It's like Einstein, Feynman, we're all really good at this kind of stuff. Like small example of a thing to play with it, to try to understand it. So that, and obviously now with Tesla, you help build a team of machine learning like engineers and a system that actually accomplishes something in the real world. So given all that, like what was the soul searching like?
Well, it was hard because obviously I love the company a lot, and I love Elon, I love Tesla. I want it was hard to leave. I love the team basically. But yeah, I think I would be potentially like interested in revisiting it, maybe coming back at some point, working in Optimus, working in AGI at Tesla. I think Tesla is going to do incredible things. It's basically like, it's a massive, large-scale robotics kind of company with a ton of in-house talent for doing really incredible things. Yeah. And I think human robots are going to be amazing. I think autonomous transportation is going to be amazing. All this is happening at Tesla. So I think it's just a really amazing organization. So being part of it and helping it along, I think was basically I enjoyed that a lot. Yeah, it was basically difficult for those reasons because I love the company. But, I'm happy to potentially at some point come back for Act 2. Mm-hmm. But I felt like at this stage, I built the team, it felt autonomous, and I became a manager, and I wanted to do a lot more technical stuff. I wanted to learn stuff. I wanted to teach stuff. And I just kind of felt like it was a good time for a change of pace a little bit.
What do you think about Optimus, about Tesla Bot? Do you think we'll have robots in the factory and in the home in 10, 20, 30, 40, 50 years?
Yeah. I think it's a very hard project. I think it's going to take a while. But who else is going to build human robots at scale? Yeah. And I think it is a very good form factor to go after because, like I mentioned, the world is designed for humanoid form factor. These things would be able to operate our machines. They would be able to sit down in chairs, potentially even drive cars. Basically, the world is designed for humans. That's the form factor you want to invest into and make work over time. I think there's another school of thought, which is, okay, pick a problem and design a robot to it. But actually designing a robot and getting a whole data engine and everything behind it to work is actually an incredibly hard problem. So it makes sense to go after general interfaces that, they are not perfect for any one given task, but they actually have the generality of just with a prompt with English able to do something across. And so I think it makes a lot of sense to go after a general interface in the physical world. And I think it's a very difficult project. I think it's going to take time. But I see no other company that can execute on that vision. I think it's going to be amazing. Basically physical labor. Like if you think transportation is a large market, try physical labor. It's like insane.
Well, but it's not just physical labor. To me, the thing that's also exciting is social robotics. So the relationship we'll have on different levels with those robots.
Yeah,
that's why I was really excited to see Optimus. Like people have criticized me for the excitement, but I've worked with a lot of research labs that do humanoid-legged robots, Boston Dynamics, Unitree. There's a lot of companies that do legged robots, but that's the elegance of the movement is a tiny, tiny part of the big picture. So integrating the two big exciting things to me about Tesla doing humanoid or any legged robots is clearly integrating it into the data engine.
Mm-hmm.
So the data engine aspect, so the actual intelligence for the perception and the control and the planning and all that kind of stuff, integrating into this the fleet that you mentioned, right? And then speaking of fleet, the second thing is the mass manufacture, just knowing culturally driving towards a simple robot that's cheap to produce at scale. Yeah. And doing that well, having experience to do that well, that changes everything. That's why that's a very different culture and style than Boston Dynamics, who, by the way, those robots are just the way they move. It's like it'll be a very long time before Tesla can achieve the smoothness of movement. But that's not what it's about. It's about the entirety of the system, like we talked about, the data engine and the fleet. And that's super exciting. Even the initial sort of models. But that too was really surprising, that in a few months you can get a prototype.
Yep. And the reason that happened very quickly is, as you alluded to, there's a ton of copy-paste from what's happening on the autopilot. Yes. A lot. The amount of expertise that came out of the woodworks at Tesla for building the human robot was incredible to see. Basically Elon said at one point, we're doing this. And then next day, basically, all these CAD models started to appear, and people talking about the supply chain and manufacturing, and people showed up with screwdrivers and everything the other day and started to put together the body. And I was like, whoa, all these people exist at Tesla, and fundamentally building a car is actually not that different from building a robot. The same, and that is true, not just for the hardware pieces, and also let's not forget hardware, not just for a demo, but manufacturing of that hardware at scale is a whole different thing. But for software as well, basically this robot currently thinks it's a car.
It's going to have a midlife crisis at some point.
It thinks it's a car. Some of the earlier demos, actually, we were talking about potentially doing them outside in the parking lot, because that's where all of the computer vision was working out of the box.
That's funny.
Instead of inside. But all of the operating system, everything just copy-pastes. Computer vision mostly copy-pastes. I mean, you have to retrain the neural nets, but the approach and everything, and data engine and offline trackers and the way we go about the occupancy tracker and so on, everything copy-pastes. You just need to retrain the neural nets. And then the planning control, of course, has to change quite a bit. But there's a ton of copy-paste from what's happening at Tesla. And so if you were to go with the goal of okay, let's build 1 million human robots, and you're not Tesla, that's a lot to ask. If you're Tesla, it's actually it's not that crazy.
And then the follow-up question is then how difficult, just like with driving, how difficult is the manipulation task, such that it can have an impact at scale? I think, depending on the context, the really nice thing about robotics is that unless you're doing manufacturing and that kind of stuff, is there's more room for error.
Yep.
Driving is so safety critical, and so that and also time critical. A robot is allowed to move slower, which is nice.
Yes. I think it's going to take a long time, but the way you want to structure the development is you need to say, okay, it's going to take a long time. How can I set up the product development roadmap so that I'm making revenue along the way? I'm not setting myself up for a 0-1 loss function where it doesn't work until it works. You don't want to be in that position. You want to make it useful almost immediately, and then you want to slowly deploy it and
at scale,
generalize it at scale. And you want to set up your data engine, your improvement loops, the telemetry, the evaluation, the harness, and everything. And you want to improve the product over time incrementally, and you're making revenue along the way. That's extremely important, because otherwise you cannot build these large undertakings, just like don't make sense economically. And also from the point of view of the team working on it, they need the dopamine along the way. They're not just going to make a promise about this being useful. This is going to change the world in 10 years when it works. This is not where you want to be. You want to be in a place like I think Autopilot is today, where it's offering increased safety and convenience of driving today. People pay for it, people like it, people purchase it. And then you also have the greater mission that you're working towards.
Mm-hmm. And you see that, so the dopamine for the team, that was a source of happiness.
Yes, 100%. You're deploying this, people like it, people drive it, people pay for it, they care about it. There's all these YouTube videos. Your grandma drives it. She gives you feedback. People like it. People engage with it. You engage with it. Huge.
Do people that drive Teslas like recognize you and give you love? Like, hey, thanks for the this nice feature that it's doing.
Yeah, I think the tricky thing is like, some people really love you. Some people, unfortunately, like you're working on something that you think is extremely valuable, useful, etc. Some people do hate you. There's a lot of people who like hate me and the team and the whole project. Mm-hmm. And I think
are they Tesla drivers?
Many cases they're not, actually.
Yeah, that's actually makes me sad about humans, or the current ways that humans interact. I think that's actually fixable. I think humans want to be good to each other. I think Twitter and social media is part of the mechanism that actually somehow makes the negativity more viral, mm-hmm. that it doesn't deserve, like disproportionately add of like a viral boost to the negativity. But like I wish people would just get excited about, so suppress some of the jealousy, mm-hmm. some of the ego, and just get excited for others. And then there's a karma aspect to that. You get excited for others, they'll get excited for you. Same thing in academia. If you're not careful, there is a dynamical system there. If you think of in silos and get jealous of somebody else being successful, that actually perhaps counterintuitively leads to less productivity of you as a community and you individually. I feel like if you keep celebrating others, that actually makes you more successful.
Yeah.
And I think people depending on the industry, haven't quite learned that yet.
Yeah. Some people are also very negative and very vocal, so they're very prominently featured. But actually, there's a ton of people who are cheerleaders, but they're silent cheerleaders. And when you talk to people just in the world, they will all tell you, oh, it's amazing, it's great. Especially like people who understand how difficult it is to get this stuff working. Like people who have built products and makers, entrepreneurs, like making this work and changing something is incredibly hard. Those people are more likely to cheerlead you.
Well, one of the things that makes me sad is some folks in the robotics community don't do the cheerleading, and they should. There's because they know how difficult it is. Well, they actually sometimes don't know how difficult it is to create a product at scale, right?
Yeah.
To actually deploy in the real world. Yeah. A lot of the development of robots and AI systems is done on very specific small benchmarks, and as opposed to real world conditions.
Yes. Yeah, I think it's really hard to work on robotics in academic setting.
Let me ask you about AGI. What are some moonshot ideas you think might make significant progress towards AGI? Or maybe another way is, what are the big blockers that we're missing now?
So basically, I am fairly bullish on our ability to build AGIs. Basically, automated systems that we can interact with and are very human-like. And we can interact with them in the digital realm or physical realm. Currently, it seems most of the models that sort of do these sort of magical tasks are in a text realm. I think, as I mentioned, I'm suspicious that the text realm is not enough to actually build full understanding of the world. I do actually think you need to go into pixels and understand the physical world and how it works. So I do think that we need to extend these models to consume images and videos and train on a lot more data that is multimodal in that way.
Do you think you need to touch the world to understand it also?
Well, that's the big open question, I would say, in my mind, is if you also require the embodiment and the ability to sort of interact with the world, run experiments, and have data of that form, then you need to go to Optimus or something like that. And so I would say Optimus in some way is like a hedge in AGI, because it seems to me that it's possible that just having data from the internet is not enough. If that is the case, then Optimus may lead to AGI, because Optimus to me, there's nothing beyond Optimus. You have like this humanoid form factor that can actually like do stuff in the world you can have millions of them interacting with humans and so on. And if that doesn't give rise to AGI at some point, like I'm not sure what will. So from a completeness perspective, I think that's a really good platform, but it's a much harder platform because you are dealing with atoms and you need to actually like build these things and integrate them into society. So I think that path takes longer, but it's much more certain. And then there's a path of the internet and just like training these compression models effectively on trying to compress all the internet. And that might also give these agents as well.
Compress the internet, but also interact with the internet.
Yeah.
So it's not obvious to me. In fact, I suspect you can reach AGI without ever entering the physical world. And which is a little bit more concerning because that results in it happening faster. So it just feels like we're in boiling water. We won't know as it's happening. I would like to. I'm not afraid of AGI. I'm excited about it. There's always concerns, but I would like to know when it happens.
Yeah.
And have like hints about when it happens. Like a year from now, it will happen. That kind of thing.
Yeah.
I just feel like in the digital realm, it just might happen.
Yeah. I think all we have available to us, because no one has built AGI again. So all we have available to us is there enough fertile ground on the periphery? I would say yes. And we have the progress so far, which has been very rapid. And there are next steps that are available. And so I would say, it's quite likely that we'll be interacting with digital entities.
How will you know that somebody has built AGI?
It's going to be I think it's going to be a slow incremental transition. It's going to be product-based and focused. It's going to be GitHub Copilot getting better. And then GPTs helping you write. And then these oracles that you can go to with mathematical problems. I think we're on the verge of being able to ask very complex questions in chemistry, physics, math of these oracles and have them complete solutions.
So AGI to use primarily focus on intelligence, so consciousness doesn't enter into it.
So in my mind, consciousness is not a special thing you will figure out and bolt on. I think it's an emergent phenomenon of a large enough and complex enough generative model, sort of. So if you have a complex enough world model that understands the world, then it also understands its predicament in the world as being a language model, which to me is a form of consciousness or self-awareness. And
so in order to understand the world deeply, you probably have to integrate yourself into the world.
Yeah.
And in order to interact with humans and other living beings, consciousness is a very useful tool.
I think consciousness is like a modeling insight.
Modeling insight.
Yeah, you have a powerful enough model of understanding the world that you actually understand that you are an entity in it.
Yeah, but there's also this, perhaps just the narrative we tell ourselves. It feels like something to experience the world. The hard problem of consciousness. Yeah. But that could be just a narrative that we tell ourselves.
Yeah, I think it will emerge. I think it's going to be something very boring. Like we'll be talking to these digital AIs. They will claim they're conscious. They will appear conscious. They will do all the things that you would expect of other humans. And it's going to just be a stalemate.
I think there would be a lot of actual fascinating ethical questions, like Supreme Court level questions of whether you're allowed to turn off a conscious AI, if you're allowed to build a conscious AI. Maybe there would have to be the same kind of debates that you have around, sorry to bring up a political topic, but, abortion, which is the deeper question with abortion, is what is life? And the deep question with AI is also what is life and what is conscious? And I think that'll be very fascinating to bring up. It might become illegal to build systems that are capable, like of such level of intelligence that consciousness would emerge, and therefore the capacity to suffer would emerge. And a system that says, "No, please don't kill me."
Well, that's what the Lambda chatbot already told this Google engineer, right? Like it was talking about not wanting to die or so on.
So that might become illegal to do that,
right?
Because otherwise you might have a lot of creatures that don't want to die, and they will.
You can just spawn infinity of them on a cluster.
And then that might lead to like horrible consequences, because then there might be a lot of people that secretly love murder and they'll start practicing murder on those systems. I mean, there's just, to me, all of this stuff just brings a beautiful mirror to the human condition and human nature, and we'll get to explore it. And that's what like the best of the Supreme Court, of all the different debates we have about ideas of what it means to be human. We get to ask those deep questions that we've been asking throughout human history. There's always been the other in human history. We're the good guys and that's the bad guys, and we're going to, throughout human history, let's murder the bad guys. And the same will probably happen with robots. It'll be the other at first, and then we'll get to ask questions of what does it mean to be alive? What does it mean to be conscious?
Yep. And I think there's some canary in the coal mines, even with what we have today. Like for example, there's these like waifus that you can like work with, and some people are trying to like, this company is going to shut down, but this person really like loved their waifu and like is trying to like port it somewhere else, and like it's not possible. And like, I think like definitely people will have feelings towards these systems, because in some sense they are like a mirror of humanity, because they are like sort of like a big average of humanity in the way that it's trained.
But that average, we can actually watch. It's nice to be able to interact with the big average of humanity and do like a search query on it.
Yeah, it's very fascinating. And we can also, of course, also like shape it. It's not just a pure average. We can mess with the training data. We can mess with the objective. We can fine tune them in various ways. So we have some, impact on what those systems look like.
If you want to achieve AGI, and you could have a conversation with her and ask her, talk about anything, maybe ask her a question, what kind of stuff would you ask?
I would have some practical questions in my mind, like, do I or my loved ones really have to die? What can we do about that?
Do you think it will answer clearly, or would it answer poetically?
I would expect it to give solutions. I would expect it to be like, well, I've read all of these textbooks and I know all these things that you've produced. And it seems to me like here are the experiments that I think it would be useful to run next. And here's some gene therapies that I think would be helpful. And here are the kinds of experiments that you should run.
Okay, let's go with this thought experiment, okay? Imagine that mortality is actually a prerequisite for happiness. So if we become immortal, we'll actually become deeply unhappy. And the model is able to know that. So what is it supposed to tell you, stupid human, about it? Yes, you can become immortal, but you'll become deeply unhappy. If the model is, if the AGI system is trying to empathize with you, human, what is it supposed to tell you? That yes, you don't have to die, but you're really not going to like it? Is it going to be deeply honest? Like there's a Interstellar. What is it? The AI says like humans want 90% honesty. So like you have to pick, how honest do I want to answer these practical questions?
Yeah. I love AI Interstellar, by the way. I think it's like such a sidekick to the entire story, but at the same time, it's like really interesting. It's
kind of limited in certain ways, right?
Yeah, it's limited. And I think that's totally fine, by the way. I think it's fine and plausible to have limited and imperfect AGIs.
Is that a feature almost?
As an example, like it has a fixed amount of compute on its physical body. And it might just be that even though you can have a super amazing mega brain, super intelligent AI, you also can have like, less intelligent AIs that you can deploy in a power efficient way. And then they're not perfect. They might make mistakes.
No, I meant more like, say you had infinite compute and it's still good to make mistakes sometimes. Like in order to integrate yourself, like, what is it? Going back to Good Will Hunting, Robin Williams' character says like the human imperfections, that's the good stuff, right?
Yeah.
Isn't that like we don't want perfect, we want flaws in part to form connections with each other, because it feels like something you can attach your feelings to, the flaws. And in that same way, you want an AI that's flawed. I don't know. I feel like perfection is
But then you're saying, okay, yeah.
But that's not AGI. But see, AGI would need to be intelligent enough to give answers to humans that humans don't understand. And I think perfect is something humans can't understand. Because even science doesn't give perfect answers. There's always gaps and mysteries, and I don't know. I don't know if humans want perfect.
Yeah, I could imagine just having a conversation with this kind of oracle entity as you'd imagine them. And maybe it can tell you about, based on my analysis of human condition, you might not want this. And here are some of the things that you might.
But every dumb human will say, yeah. Trust me. I can give me the truth. I can handle it.
But that's the beauty. Like, people can choose.
But then it's the old marshmallow test with the kids and so on. I feel like too many people can't handle the truth. Probably including myself. Like, the deep truth of the human condition, I don't know if I can handle it. Like, what if there's some dark stuff? What if we are an alien science experiment and it realizes that? What if it hacked?
I mean, this is the Matrix, the all
Matrix.
over again.
I don't know. I would. What would I talk about? I don't even. Yeah, probably I will go with the safer scientific questions at first that have nothing to do with my own personal life.
Yeah,
and mortality, just like about physics and so on.
Yeah.
To build up, like, let's see where it's at, or maybe see if it has a sense of humor. That's another question. Would it be able to, presumably, in order to, if it understands humans deeply, it would be able to generate, to generate humor.
Yeah, I think that's actually a wonderful benchmark almost. Like, is it able, I think that's a really good point, basically.
To make you laugh.
Yeah, if it's able to be like a very effective stand-up comedian that is doing something very interesting computationally. I think being funny is extremely hard.
Yeah, because it's hard in a way, like a Turing test. The original intent of the Turing test is hard because you have to convince humans. And there's nothing, that's why when comedians talk about this, like, this is deeply honest. Because if people can't help but laugh, and if they don't laugh, that means you're not funny. If they laugh, it's funny.
And you need a lot of knowledge to create humor about, like you mentioned, human condition and so on. And then you need to be clever with it.